Good morning, students. In previous class, we already discussed about natural numbers, which are starting from 1 to 3, so on. Whole numbers. When we are adding 0 to that natural numbers, we are getting that one. Integers, which means negative numbers, 0 and positive numbers. After that, rational numbers, which are in phi by q form, where q not equals to 0 and p comma q are integers. We already discussed about different types of rational numbers. There are 5 types of rational numbers. First one, fractional form. Second one, integers form. Third one, terminating decimals. Fourth one, non-terminating recurring decimals. Fifth one, the numbers which are getting that perfect roots. These all are rational numbers. After that, today we are discussing about rational numbers. Numbers which cannot be expressed in the form of p by q, where p comma q are integers and q not equals to 0, or irrational numbers. Irrational numbers are denoted by the letter q dash. Here I am writing some examples. Irrational numbers q dash is equal to set of 2, root 2, root 3, root 5 and so on. For irrational numbers also, 3 types of irrational numbers are there. What are they? First one, non-terminating, non-repeating decimals. Decimals which neither end nor have a repeating part are called non-terminating, non-repeating decimals. For example, I am taking example 1, 5.76189324 and so on, 3.742872 and so on. When we are observing these numbers, we are unable to find how many places are there after decimal point, unable to count how many places are there, because they are not terminating, they are not repeating. So these are called as non-terminating, non-repeating decimals. These are also irrational numbers. Next one, I am taking some examples. I am taking root 1 is equal to 1 rational number. Root 2 is equal to, we are not getting perfect value. So root 2 is equal to 1.4142 and so on. Root 3 is equal to 1.7321 and so on. So here root 2 and root 3 we are not getting perfect values. They are irrational numbers. So when we are observing here, some numbers are getting perfect values, some are not getting perfect values. So if we are able to write the roots of given numbers perfectly, they are rational. Otherwise, they are irrational. For third type of irrational numbers, I am taking one example, pi, where pi is equals to 3.141592 and so on. Here, the value of pi is non-terminating, non-repeating. So, pi is an irrational number. Note, March 14th is Pi Day. And sometimes we are taking the value of pi is 22 by 7. This is the approximate value of pi. So July 22nd is approximate day of pi. So here we are observing two key points. 22 by 7 is a rational number and pi is an irrational number. Lastly, we are discussing about real numbers. What are real numbers? The union of rational and irrational numbers are called real numbers, denoted by the letter capital R. Therefore, real number set capital R is equal to Q union Q dash. To write some examples for real numbers, it is enough to write some examples for rational numbers and irrational numbers, because rational numbers plus irrational numbers equal to real numbers. So I am writing some examples for rational numbers. For rational numbers, 5 types already we are explaining. I am taking that examples: fractional form, integers, terminating decimals, non-terminating recurring decimals, the numbers which are having a perfect roots. For that, I wrote some examples. After that, for irrational numbers, I wrote some examples: 3.742 and so on, root 3, root 7, root 11, pi, so on. Non-terminating, non-repeating decimals which are not having a perfect value. So real numbers set capital R equal to rational numbers plus irrational numbers I wrote here. We observed here there is no number that belongs to rational and irrational. rational irrational నంబర్ అయ్యే విధంగా ఏ నంబర్ కూడా లేదు. రియల్ నంబర్ సెట్. దిస్ రియల్ నంబర్ సిస్టమ్ అబ్జర్వ్ హియర్. నేచురల్ నంబర్ సెట్ subset of whole number subset of integers subset of rational numbers. These rational numbers plus irrational numbers equals to real numbers set.